Hey all, I'm going to be running through a few of the challenges in the Hack the Box Business CTF. The first one was the Impossimaze challenge. So when you open the window, you get a screen. On that screen, on the top left, it shows the aspect ratio, or more so, the characters in the terminal, the width and the length. And then in the middle, you have an X. It generates this random maze, and you can walk around in the maze. There's no set. The start point is the middle of the screen. There's no set endpoint. So obviously there's more to it than just playing the game. We open up the binary in Ghidra, which shows an entry point function. When you click the entry point function, it's called ellipses start main with fun001 blah blah blah. We double click that to go into the actual start function. In there's a few API calls that we can see, or even just from context guess what it does. When I like to start, I like to label those functions. So here I've basically done the bare minimum labeling just to get the point across. But we see that x and y are the width and length of the screen. Those are divided by 2, and that's the current character position, because you start at the center of the screen. And then there's also a check for the max x and y, which is the number that gets displayed in the top left, and also the size of the terminal in characters. Now halfway through the program, there's this, like in the same function, there's this check. If screen size is 0xd and screen size y is 0x25, which is 1.3 and 3.7. And sure enough, there's the flag. Second challenge, crystal corruption. This is a machine learning one. We get a path file, or a checkpoint, and when we load this into PyTorch, we get it actually executes code on our device. This is why safe tensors are a thing, to prevent this from happening. So when you're trying to download machine learning models, make sure to use safe tensors. But this challenge is interesting. So I tried to find where in the binary or the PTH file this code was loaded, and it turns out it's at the very top. So I do cat piping headman n40, so these are the first 40 lines, and you see the code itself. Now in this code, it decodes the payload and then actually calls exec.payload or exec.payload.decode. And it also here says system set trace, so you can't do any attaching for there, unfortunately. But what we can also do is we see that this actually, this taps into the tensor, so we can just load the tensor file in the process, also running the code again, Lamau, and then just straight up using their code to get the data out. And then this is the code that actually, so here you first see the connecting, delivering, executing, blah blah blah. And then you actually see the code, which is simply import OS, blah blah, print some strings, and then a hidden flag. The third one is the most interesting one out of the three. It starts up an IRC chat service, and called mini IRC service. And it has the normal things you can do. You have a join command, list channels, show the names of the member in the channel, disconnect. It encrypts the messages in the channel, so you don't actually see the unencrypted messages, you see the encrypted ones. The key is a urandom32, and the counter, it's AES in counter mode. The counter is counter.new128, which means for every message, the counter will start at 0 and just count up. The issue with this is that the key and the counter are the same for every message. And furthermore, the combination of the key and the counter is XORed with the plaintext to become the ciphertext. So if we have the plaintext XOR the key is ciphertext, then the plaintext XOR the ciphertext is the key. And when we have the key, we can get the plaintext back. So what we do here is say we have a known plaintext and a known ciphertext, which we get. And then we can extract the key stream by XORing again with each other. Then say we have a new plaintext and a new ciphertext, which is again with the same IV and key. Then given we don't know the plaintext, we can recover the plaintext using the key. And the way this works is these are what the messages look like, but because it's IRC, we can guess what the first and last messages are. These are nickname messages and leave messages. So from here we can see that the fourth message was Nick Roomblight, and we get the X from there. In there we can, we can take, this is the key stream, and what are the messages then? And then we can continue enumerating. So okay, we have this plain text. What other plain text can I guess? So just from the first nick, we can see on number 5, I've been studying. So then I can enter number 5, and my guess is I've been studying. And then we can see, okay, number 6 I'm already cross. That's probably cross-examining or cross-checking or whatever, something like that. And then we can continue that until we get the whole thing. And then a flag comes running out. So that's my write-up of some of the challenges of the Hackthebook CTF.